Okay, so we're talking about projectile motion today. When you launch a projectile, it starts at a certain height. In other words, if you throw something to your friend, that ball that you're throwing to your friend, for instance, would start at a certain height, however high it is when you are about to toss it. Okay? So this is the height, and this is time. It is not distance. People really get that confused because after the graph comes out looking like this, they think, oh, that's how far the ball went. No, it's not. What's that distance? How long the ball was in the air. Very good. Okay. Now, if you have a projectile that's been launched like this, there's an equation for it. Y equals. You ready? You have to write down a big equation. Okay. Y equals 1/2 g x squared plus v sub 0 x plus h sub 0. That is not ho. It is h sub 0. Okay. So, in this, there's a bunch of variables. There's g, does not stand for gangster. It stands for, what do you think? Gravity. The gravitational constant. Okay? And it is technically negative 9.8 because then that'll make the parabola be upside down like this. Okay? So negative 9.8 is correct for the gravitational constant. And that is in meters per second. Then, velocity. You're thinking about like the speed of light, or the E equals mc squared. That has... Anyway, moving on. V0 is the velocity. The velocity as in, if you throw a ball, can you picture that if you throw it really hard versus throwing it softly, it's going to go higher, right? So how hard you're throwing that ball up in the air makes a difference. Okay, so the velocity is how hard you're throwing that ball. And the next one is the initial height, as in your starting height. So, if I told you this situation, we had a Super Bowl, and we were going to throw it up here on the planet Earth, which means we'd use negative 9.8. If you were on the moon, there is a different gravitational constant that they can use. All right? And if you get farther and farther and farther away from something, does gravity eventually lose its pull? Yeah. If you think about it, if you get up into space, you're just floating around, right? Because you're far enough away from the Earth that it's not pulling you towards it. By that same token, shouldn't gravity get stronger and stronger as you go towards the center of the Earth? Does that make sense? So what happens if you're at the very center of the Earth? Which way do you get pulled? You explode. You melt because the center of the Earth is molten.
You get sucked in yourself.
Ooh. All right. So anyway, then this Super Bowl, we have to tell how fast we're going to throw it up into the air. And if we measured the other speed in meters, we better measure this one in meters also. So in meters per, what do you think? Second. So the velocity in meters per second. Now think about it for a second. If I throw a ball up in the air, just give me a speed you think is reasonable that somebody could throw. How many meters do you think a ball would go in 1 second? You know, 1/1000. How long do you think?
40 meters per second. 6, 10, 3, 8.
I'm going to use 8 because it's a nice number that's not made up like 10. 10 is really nice, but I'm going to use 8. Okay, 8. And then x plus, 10 is really nice, but it seems like it's made up. And besides, to be honest, it's the homework one. So I want to do something else. Initial height. Well, how high up are you when you're standing holding a Super Bowl in meters? Okay. You're going to start throwing the ball at your head, though? Aren't you going to start throwing the ball at maybe... That's true. It's where you release it. So if you were throwing it up above your head, I could give you that. So what's 6 feet about in meters? 2. All right, so there is a very realistic equation for throwing a Super Bowl. I know some of you are shorter than that, but okay. So it's wherever you release the ball, then that's, at that moment, the ball's going up. Now, one more thing that we are not accounting for in this equation. The angle at which you throw the ball.
Yeah.
Because if you throw the ball super fast but at a really low angle, it doesn't go up that much at all, does it? Okay, if you throw it straight up, that's what this is about. Technically, we're throwing the ball straight up in the air. And again, kids look at this picture and they think, doesn't this mean that it's going, you know, this far away from where it started? No, that's not a distance, that's a time. Okay, so technically, we're just throwing it straight up in the air. Now, parabolas are much more fun to see in the real world if you actually throw them like with a little bit of side-to-side motion. So we're going to grab these Super Balls and do something fun with them here for a minute. Okay, so we're back from lunch and we're doing the first problem on the worksheet called projectile motion. And it asks about an equation for that situation. You always start with y equals 1/2 and then you put in g, negative 9.8, and that's x squared. Plus the velocity in this case is 44x plus the height 200. That is correct. And that's all in meters. Okay, so then there's my equation for A. And now my first step would be to put that into a calculator because I'm going to show you, remind you, I hope you've already learned this, how to find the main spots on the graph. All right, so start by typing in on your y equals screen. Let me see if I can get this a little bit smaller here. All right, y equals, I'm going to clear that out, negative, is it 9.8 or does it shrink down to, well, but isn't it half of 9.8, so it's negative, what's half of 9.8? Negative 4.9x squared. You know what I'm saying there? Negative 4.9x squared, okay. So negative 4.9x squared. Oh, I just put to the negative 1. It would be it's really hard to see on this smartboard. It's a huge screen, but you can't like see where things like squared are. It's hard to tell the buttons apart. All right, now I gotta get that off of there. The 4.9 isn't squared. Clear that. Clear that. Man. Here. I want to clear. There. X squared. There we go. Oh, took forever. Plus 44x plus 200. Okay, sorry that took so long, but there it is. Now for your graph, hit graph, and I bet yours, like mine, isn't going to look real nice. You need to zoom it to a nice zoom. There's zoom 6 is the standard zoom, but that's not going to work real nice. Try zoom 0. Zoom 0. Okay, did you type zoom 0 yet? Do zoom 0. You're zoomed into a funny place on the graph is why it's not looking right. Question? Okay, it should look like mine does if you did a zoom 0 and you typed in the same equation that I have. If not, if yours is looking all goofy, you probably have the wrong equation then, if you've tried zoom 0. Okay, so back to, what do we need to figure out here? The first question said to write the equation. The second question says, after 4 seconds, how high is the ball above the riverbed? All right, after 4 seconds, are they telling me an X or are they telling me a Y? Which one is time? X. So they're telling me that X is 4. Now you could do this with the trace feature, but it would take forever. So watch, this is a smart way to do it. Go to right above the trace button, there's a calculate. So you go second, calculate, and we want a value, the very first one there. So hit a 1. And now see how an x equals pops up on your screen? It has an x equals a blinky thing. Well, didn't it just tell us what x was in part B there? X is 4, so you type in 4. X equals 4, enter. And now it tells me if x equals 4, then y equals 297.6. What is that telling me? At time 4, the y, or the height, is 297.6. All right. Okay, so I paused there because there were a bunch of kids saying that their graphs looked a little different. As long as when you type in x, the value thing, x equals 4, you got 297.6, then you could tell that your equation is doing it right. You know, there's nothing wrong, it's just your picture looks a little different, and that's okay. All right, so that value thing, that's when they tell you an x. Let's go back and do another part here. At what time does the ball land at the bottom of the riverbed? Can you picture that that's when it touches the ground right here? See, it's going to have the height is equal to 0. So we want to find this spot right here. So how do we find that? That's called an x-intercept. It's also called a root. It's also called a 0. Very good. So we need to do a 0. So we're going to go into second, calculate the 0. See that? Calculating the 0 of the graph. And now it's asked me a question. It says left bound question mark. What it wants me to do is go to the left of the 0 that I'm trying to find. And then I go to the right of the 0 I'm trying to find. And then I hit enter. Okay, so the left boundary, I don't know if you can see this, but my line goes like this. And where my 0 is right there. So I need to be just to the left of it, and then I hit enter. And then I get the little spider thing just to the right of it, and then I hit enter. All right, so my little spider thing's right near the top. So I am already to the left of it, so I can hit enter. Now it says right bound. I'm going to arrow over a little bit until I'm to the right of where my 0 is. You see how my spider is now to the right of the 0? Hit enter. Hit enter one last time, and it will tell you the 0 is at x equals 12.298 and y equals 0. That can be tricky to see. First, it asks you 3 questions. First one is left of it. The second one is go to the right of it. And the third one is, this is called guess, and that means you should kind of like get close to where you think the answer is and then hit enter. You don't really, at that last step, you can just hit enter. You don't really have to guess. All right, moving on. That is to find a 0. What's the other thing they might care about? The very top, the maximum. And that also is go to the left of it, go to the right of it, and then hit enter one more time, and it'll tell you the answer. So that's under calculate. So everybody go back. Even if you didn't get that last one, try this one with me. Second, calculate the maximum. It's number 4. Now we got to get our little spider guy just to the left of where the maximum is. Keep arrowing until your little spider gets to the left side of the peak. Hit enter. And then it says right bound. I go just to the right of the highest spot. And then I hit enter. And then it says guess. And then I just kind of move over near the middle and I hit enter. And the answer is the maximum is at x equals 4.48 and y equals 298. What does that mean? X is time. So at time 4.5 seconds, the y is the height. It's 298.7 meters. All right, so we just answered the question about how high is the ball. And that was it. That was letter That was the third. There's two C's on the worksheet. It's the second C. At what time is the ball at its maximum height? And what is the ball's maximum height? That's D. We just answered those two. Okay, now we've got to answer the question, what time does the ball land at the bottom of the riverbed? Oh, wait, we already did that one. That was the 0 one. Okay, so I have answered all 5 questions on number 1. Number 2, write the equation for the situation using that little equation at the top of the page. Then you're going to graph it. I'd use zoom 0 to get it to look nice. Then I would use the value one. This menu is really important, the one right above trace. The value tells you like an X number to put in. The 0 is where it touches the X-axis, and the maximum is the highest it ever goes. So those 3 things on your calculate menu are really handy. Okay?